Poštovani posetioci, dobar dan i dobrodošli na 55. Međunarodni kongres i izložbu o KGH-u. Današnje predavanje započinje profesor Klas Berglöf iz firme ClimaCheck. I invite today's lecturer, Klas Berglöf, to join us at the stage. Thank you.
Thank you very much. And so today's session is about how can you measure performance in air conditioning refrigeration systems. And this is something that is becoming more and more important. I mean, before it was enough if we kept the temperature. So if you had a refrigeration system and you maintained the temperature of the goods or the air conditioning in the room, then everybody was happy. So this means that there has not been focus on the performance of systems, but this is changing now with energy, shortage, and of course the climate change, where we need to use energy very efficiently. So this equipment can be hooked up to virtually any vapor compression cycle. So if you have a compressor, you can measure what it does. And traditionally, you try to measure the flow on the water or air side, and then what people have tried to do that in the field knows that it's very challenging, because of when you have a flow in the field, normally there is not calibrated flow meters and so on, so you get a very rough estimate of the flow, and then we work with small temperature differences. And if it's air, we also have the humidity. And secondly, even if you succeed in measuring the flows and the temperature differences, you have no clue on what the problem is. So what we do is that we measure in the refrigerant cycle. So the refrigerant cycle is well defined, and we can isolate the compressor, condenser, evaporator, expansion device, and refrigerant charge, how that works in the system. So you can actually get the performance on each component in the system, as well as the total COP, coefficient of performance, or energy efficiency ratio, or kilowatt per tons, whichever unit you want to use. So it changes the perspective when you, in real time, have this information. You can get it through this type of portable systems, where there is 10 measurements. You need 7 temperatures, 2 pressures, and electrical power. That is what you need to get all the information on the system. So this type of pressure sensors, they are today becoming more and more standard on all systems. And we use different ranges because the accuracy is normally dependent on, or the error is dependent on the maximum scale of the sensor. So by using adapted scales, you can maintain a good accuracy of the system depending on what you use. For temperature sensors, the good thing is that we are not so dependent on the high accuracy of the measurement as if you're measuring on a small delta T. Because if you measure on the outside of a tube, you will always have a small error. But when you look at the cycle in the pressure enthalpy chart, you can see that it's not so highly sensitive, because of most of the heat transfer is in evaporation and condensation. So we apply these, and you have to be careful when you do that. So you use aluminum tape, heat transfer paste, and insulation. We're going to show you how to do it on the system. For power, I'm much more used to use this type of size of current transformers than what we're using here, because of course, when you start measuring, of course, it's a lot of large systems that are measured, because of they use much more energy. It takes as much time and effort to measure on a small, maybe even sometimes worse, because it's so cramped everything. But this is, you can measure up to 4,000 amps with these. So you open them and you connect them around the leads when you measure power. So that can be applied easily. So this is a demonstration unit that Mr. Pekovic and his team put together for us. So it's really nice. This type of systems, they normally do not have two pressure connections directly on the compressor. So we have measured one temperature here in the condenser instead of pressure. So maybe to look at what we are measuring, if we look at the flow chart, hopefully you can see there. So the yellow values, that's measured values. So I think I'm pointing here. So we are measuring suction pressure and temperature, discharge pressure and temperature. Then we are measuring on the tube end in the condenser and air on and off the condenser and evaporator, and then the liquid line temperature of the refrigerant. So those values define the whole cycle in the system. So let's go to the back. So we show how to, we have applied some of the temperature sensors as it's very cramped here. Takes small fingers to get it there. But the important thing is that you use aluminum tape and put the sensor on that, and then put some heat transfer paste so you get good contact. So we apply these sensors on the. This is we are showing on the suction side, suction pipe of the compressor, and then we have applied one on the discharge, and one on the liquid line after the condenser. And you can use insulation tape, see if you can get. And you can also use this cut insulation and the clips for that. Normally clips for plastic bags, but they make a nice application of the sensor. So then we have also measured the voltage. On the, this is single phase, so we measure on phase and neutral, and then we have put CT on the power to the compressor. And then we have the pressure sensor here that is applied on the suction side. So those are the sensors that we need. And then we can start, and now we have data in real time on the performance of the system. So the gauge to the far left, that is the total system efficiency index. So you establish reference temperatures depending on what type of system it is. And so that then you compare, for those that have studied some thermodynamics, you are aware of Carnot efficiency. So you establish the reference temperatures for this type of unit, and there are agreements on many types. So you can compare, everybody's using the same comparator, but basically you take the COP that you have measured and you divide it by the Carnot efficiency at these conditions. And then you can split the losses on the cycle as such that is normally not something that is that you're paying most attention to, except for that if it's economizer, for example, on the system, you get a very high cycle efficiency. But then you have the isentropic efficiency of the compressor, you have the condenser efficiency, and the evaporator efficiency. So you have efficiency per component, and all these service parameters that people are used to are listed below. So I would say that this is the perfect service protocol. You can see on top there that it's running stable, so the data will be relevant. And then you can look at all these parameters that people are used to: superheat, subcool, temperature differences, approach. But it's also visualized in the graphs. So it gives you a very good understanding of the system. And you can also, if you want to, a lot of people want to see it this way because people are used to see it. To me, this doesn't tell you so much. You want to see that you have subcool and that you have superheat. But otherwise, the dashboard is much more valuable. And the white area in the middle was when we were hooking up the system, so there is no data. And you can zoom in this, but we can see that it's very stable operation of the unit. But many times you have issues when it comes to expansion valves or changing parameters in the system and so on. So the graphs are very useful. And of course, you have all the data is logged. So this contains, I would say, all parameters, and we're only highlighting the main parameters. Every enthalpy point, every variable is there. So it contains all the data to analyze the systems and troubleshoot it. Yes, so I think that's basically showing all the information that is there. I hope there are some questions. I think that you probably will enjoy to go over and look at what we are, how it's done and so on, but that you have to do in person, so to say. And you can ask, you can come over.
Can this software be installed on almost any laptop, or the requirements are high? And how it's
yeah. The software works on any, I mean, I don't think you can buy a Windows computer that it does not work on today. So it's not requiring a lot. And I should also say that also the portable system can send the data to the cloud. Actually, we are sending the data to the cloud in parallel now. And for troubleshooting and so on of problems that are not obvious when you are there, but are happening when you're not there, logging is very efficient. And also the ClimaCheck Online platform is, of course, most of the systems are there continuously for 24/7 monitoring, where you can put alerts on any deviation in performance. As you have the total performance and you have performance on component level, you can follow and give early warning for any deviation, which I will talk more about in the presentation tomorrow. More questions?
Скажите, пожалуйста, вот ваша программа дает рекомендации по оптимизации работы холодильной системы. Можно ли эту программу использовать систему мониторинга не вашей фирмы, а вообще другой фирмы, которая уже смонтирована на агрегате?
this system is used for monitoring of refrigeration system. Could it be used for monitoring of other system already installed on the customer's refrigeration system?
I mean, we have supplied several thousand systems all over the world. I mean, we have one supermarket chain in Greece. They have 300 supermarkets connected. We have connected 1,400 supermarkets from Edeka in Germany. We have hospitals, hotels, a lot of food and drink industry are connecting because they're also focusing on energy consumption now. A lot of heat pumps. So the smallest systems we have been working with is 90-watt input for vaccine coolers, and the largest are 9 megawatt power to one compressor for district heating cooling. So anything with a compressor.
Maybe I do not 100% understand your answer. My colleague asked if they already have system of sensors produced by other manufacturers. Can it be?
Yeah. Most systems that are connected to our cloud platforms today, we don't supply any sensors. So because of we Carrier, Johnson Control, Hitachi, Mitsubishi, all these, I mean, they would have almost all sensors installed from the factory. Many times the liquid line temperature is not there. So the trend now is, of course, that all chillers and heat pumps are connected to a BMS, a building management system. So they are connected there, and they read the data up to the building management system. And if there is a sensor missing, they put it in the building management system. And then the building management system, some of them are today capable of sending data to a third-party server. Or they can write on Modbus to a gateway. So then we get the data from this gateway or over an API directly to the servers. So that is, of course, a trend. It's that not all systems will be specialized on everything, but and you want to move the data from the facility because you cannot have expertise for everything in every facility. So you need to bring the data where you can use servers to find where you should look, and then you have experts looking at those sites where you are having problems. Because there are so many sites, and you cannot have experts on all of them.
So thank you very much, Klas. Very interesting demonstration. Question, would it be feasible that a refrigeration association owns maybe 2 or 3 units and provides these services to companies in the country, maybe every couple of months, to measure the performance of a supermarket? Or is that kind of system already existing somewhere?
I think that we send these type of systems out to customers with the manual, and many times they have no problem with using it. But there is a lot of information, so it's not something that somebody use once. And so, I mean, because you need to get used, many in the industry is not used to laptops, I mean, more than that it's setting up something on a controller or something like that. But they're not very familiar with something like the spreadsheet that you have there. So I think that there are many engineers, technicians who like it. And it should be under control of somebody who wants to do good things with energy optimization, troubleshooting, and so on. So it's not something that you send around to this person, this person, this person. You need to, I mean, we always recommend companies that start using performance monitoring to get somebody who is preferable 2 people that are the first ones to learn and to start building experience. Then they can train other ones. Because we have had some customers who, when they have a problem, they take any technicians, tell them to go out, and they don't know what to do. I mean, they get confused when they start, and there's different questions and fill in data here. So you need to have an interest, but then you can pick up experience very quickly. So, I mean, you can absolutely have some a team that goes around and do things. That's perfect, but focus on some people building experience, and then they involve more and more people. Not that everybody is involved from the beginning, because of you need to have the desire to learn, and you need to be interested. Then there is a huge, a very quick learning curve when you have all this information in front of you.
Thank you very much. What could be the synergy between measuring the performance of air conditioners and refrigeration systems and leakage check?
Yeah. So I mean, you can say that any time you have a change of refrigerant charge, it's going to affect your performance. I mean, there's in EU regulations, there is something called indirect leak detection. So if you have a system that will, based on pressures and temperatures and so on, detect when the refrigerant charge is changing, you can reduce your on-site visits for leak detection to half. And I would say that, of course, there are systems that are very easy to leak check with a leak tester, but most systems, it's really difficult. I mean, like if you're going to leak check this system, you know, the evaporator is up there, and the condenser is out there, and there's wind. It's virtually impossible to find most leaks unless they are just around the compressor and so on. So whereas if you're monitoring the performance, you are going to detect if the refrigerant is changing. And also there's which I will cover more in the presentation more, but now when we are applying AI, digital twins, it becomes extremely powerful because of all these parameters. They are dependent on the operating conditions. So if it's 40 degrees outside or 20 degrees outside, makes a difference. The indoor temperature, so all these are very dynamic. So on most systems, I would say that refrigerant charge is very much defined by the subcool in the condenser, because of your expansion device control the flow to the evaporator, and the buffering is done in the condenser. So by the subcool, you see how much refrigerant is in the condenser. So if you monitor the subcool, that's a very, very good indicator on leaks. But at the same time, it varies. It could be 3 degrees at one condition and 8 degrees on another condition. And this varies depending on the design and so on. So by using a digital twin that learns what the subcool is for this type of system, it doesn't need to be the same system, but this type of system, then you don't need to know that it should be 3 here, 4 here, 5 here. The digital twin tells you that this is the expected value, this is where you are. So then you can fine-tune your early warning extremely easy with digital twins. So that's going to be a game changer because it saves so much time and contains so much experience in the digital twin.
The very final question from my side. Would you qualify the system as mobile or stationary?
I mean, this is absolutely a portable system. I mean, I would say that I might need half an hour, 40 minutes to connect to this because it's so cramped. But to a chiller, you connect it in 20 minutes without that it's prepared in any way. But again, as said before, most of the sensors are already there. So, of course, the trend and what's going to change the service market is that data is brought to the cloud because it's so cost effective. Yeah, this is a portable system, but I think that there would. Yeah, I mean, I think it's if the system has to be done, or if the performance need to be monitored permanently, or of course it's better to check the performance at some time. So that's much better than not doing it. But of course, to do it continuously 24/7 is the best. And if you're talking about larger systems, it's obvious that permanent monitoring is worth it. On smaller systems like this one, when sensors are there, and if you have a modern BMS and you have cloud communication for data and so on, you can do a very small system permanent cost effectively. But of course, it's a big difference if you have a 5 kilowatt compressor or 1 kilowatt compressor, or if you have a 100, 200 kilowatt compressor. The cost effectiveness, of course, increases because the cost of monitoring is more or less the same regardless of size, whereas the savings are extremely much higher.
I am Vasil Evtimov. I would like to ask you a question on applicability, taking in consideration the system nowadays are designed with frequency-driven compressors, with frequency-driven fans, and the system is constantly changing everything. And when you monitor, you will always see the subcooling and the superheat will be perfect if you have electronic expansion valve. Because the system is trying, in case of malfunction, is trying to put himself in a comfort zone.
I wish I could agree with you that the electronic expansion valves are always functioning perfectly. That's not my experience. I would say that I've virtually never seen any system that cannot be improved. Because today's commissioning and so on is not done in a way where you adapt to the flows, to the conditions, and to the system. So there is I like electronic expansion valves.
I'm not speaking about the valves. I'm speaking about different things. Now, if we change due to the filter, dirty filter, now we will change the airflow. Changing of the amount of air flowing to the system will, is this a frequency-driven compressor?
Yeah, I mean,
No. The question is following. The system will try to adapt to achieve on the refrigerant side the design conditions, and the efficiency will flow down because of the dirty filter. In case of water system, if you have a bad water flow, it will influence the work and the efficiency of the unit. But if the system is running on frequency-driven compressor, if the system is running on a frequency-driven fans, in this case, then the system, the refrigerant side will try to adjust to this. How can you monitor this on your software? This is my question.
Yeah,
not directly to the expansion valve. And I strongly disagree about the expansion valve because the electronic expansion valves are working perfectly if you have a precise measurement of the pressure and the temperature.
Okay, I mean,
so we don't go back to the thermostatic valves. Absolutely.
No, but I don't know. I mean, you measure what happens in the system, and I agree. There is coming variable speed drive compressors and fans and so on that offers an opportunity of energy efficiency. I would say that I see that they're not well adjusted also with these devices many times. There are many of the systems that have very erratic controls. You're revving up your compressor up and down and your fans, and they are chasing each other. It's extremely common when you see how the system is performing. We measure what's happening. So I think it's a good to verify that it's working fine. I wish there were more systems that we could only say that this is working fine, so you don't need to pay any attention to anything. But I would say that we see a lot of potential improvements with variable speed, but we don't see that they're tuned as they should be. But it's always interesting to verify that it's working, even if it's working perfectly.
The tuning comes from the qualification of the personnel of the service technicians. Comes from here. So
I mean, I agree that.
I never said that.
But the first, I mean, the challenge in the industry today is that there is a specification going out for a site. That does not. It's very rare that it includes that the system should be commissioned, including checking that it works at different operating conditions, different outdoor conditions, different loads. So we see many systems that they commission and they say it works perfectly. And then you see that when it gets colder outside or warmer outside, or when they turn off the system at night, you have terrible operation. So you need to first change how you purchase systems, so you put requirements on the people installing that they actually verify performance of the system in the plant. Because most problems I come across, they are very obvious, but then the supplier says it's the contractor, and the contractor says it's the plumber, and the plumber says it's the BMS. So everybody's just chasing each other on whose fault it is, instead of fixing the problem. If you specify from the beginning that it should be verified performance, then people talk together because they have to do that to get the system past the inspection. So, I mean, you have to measure is to know. So you have to measure, and then I think that there is a learning curve, but it's really needed.
Okay. I will stop. I will not comment. Maybe later we can discuss.
Any other?
There is a huge interest among the participants to see the malfunctioning of the system. We wonder whether we can simulate the malfunctioning now so that the system generates the recommendations.
I would say that we have not set up any limits for this particular. I saw this system the first time now. But you could say that when you look at, for example, compressor efficiency, that is very general for, I mean, a very good compressor today is about 70% compressor isentropic efficiency, regardless of which brand or which type. And so many of these are quite obvious and global. But when it comes to the warnings, you need to adapt them to the type of system that you are operating with. So there are some this is what we work with in the trainings and so on. I mean, you could of course change the but I mean,
what if we release some refrigerant now? That's not me, that's him.
You would see how it changed as a subcool, but for obvious reason we will not do that. I mean, yes. So I would say that this is if you work with, most engineers, technicians would work maybe on this type of system or that type of system, and when they've seen one working well, they see the deviations immediately, and you can set deviation on any of these parameters. And we, of course, have a lot of, say, templates for what deviations you detect. But I mean, you could, of course, stop the airflow, but then it will just trip. So that would not be really, I mean, the unique benefits of this is that you see deviations when they are occurring. So it's not that it's an alarm, it's a early warning before it goes down.
And whenever there are deviations observed, there is a list of recommendations coming?
I would say that that is something that we are working on. I think that to some extent, some of it is. So, yeah.
Система четко указывает отклонение от нормы. Ты видишь, какие отклонения от нормы.
We have some recommendations, for example, that if the condensing pressure goes up, so your condenser efficiency goes down, then that could be a flow-related problem. That could be a overcharge of refrigerant. So we have some of these general guidelines that is there.
Стандартные рекомендации, что если... Да, предельно они... Да, да.
А потом, когда вот, допустим, приобретем, они поддержку, которую делают туда, программу, совершенствование программу.
And there is definitely a client support, after-sale client support from you.
I think that we are quite known for supporting. I mean, we have installed TeamViewer in the software, so we can actually, as long as you can connect your laptop on site to internet, and then we can go in and we can see what's happening on your computer, so we can have a dialogue and support. So I think that that's how we work. I mean.
And what about the software updates?
Yeah, so we have during the first year, all upgrades are included, and then we have a support agreement which will both update the software, but also if you call us and say, I don't understand what's happening here, then we can go in with TeamViewer and we can support. So there is a support agreement where we will continue that as long as people use the support agreement. I will be here for the whole session, so you can ask questions anytime you like. So if anybody wants to go over and look at the sensors and how it's connected and so on, I will go behind there and be available.
So it's still working? Yes. So I would just say thank you very much, Klas, for the demonstration, and thank you everybody to come. I would like also to thank our technicians who prepared everything, and Slobodan Pekovic, and also the main sponsor who offered to provide the equipment. So thanks to everybody involved. And participants of the ECA network, we meet again in room number 3. Yeah? Thank you very much, Klas.